Okay, hi guys. This is in response to a query from James about a question in the 2015 TASC paper, calculator section, question 28, a question about tides and how to model them using a circular cosine sine function. Okay, let's get started. A boat left Hobart at high tide at 2 p.m. on Tuesday. The high tide at this time was measured at 1.7 metres. The boat returned to Hobart at low tide at 11 a.m. on Wednesday. The low tide at this time was measured at 0.5 metres. While the boat was out to sea, there was one low tide and one high tide. Determine an equation that models the tidal height as a function of time in hours since midday, 12 noon on Tuesday. Okay, excellent. Right, so if we just do a quick sketch, it's always going to be helpful to figure out what's going on. So here we go. So this is going to be when the boat goes out and there's a low tide, and then there's a high tide, and then there's a low tide. Whoops, that's not what I wanted to do at all. Let's see if that works. So the boat goes out then there's a low tide, a high tide, and a low tide. So here I've interpreted what the question's been telling me. So that's when the boat leaves at high tide, and that's when the boat returns at low tide. And we are told that while the boat's out to sea, there's one low tide, which is here, and one high tide, which is here. Okay, so that helps us figure out what's going on. This is 2 p.m. on Tuesday, 2 p.m. Tuesday, and this is 11 a.m. on Wednesday. Okay, excellent. Right, well, we can start figuring out what do we know. All right, so first of all, we know that high tide is 1.7 meters, and we know that low tide is 0.5 meters. So that means that the tidal range which is the difference between high tide and low tide, is 1.2 meters. Therefore, the amplitude is equal to 1.2 meters divided by 2, because remember the amplitude is half the distance between the minimum and maximum. So we already have an amplitude of 0.6. Next, we want to find what our mean value is here. That's going to give me, remember, the vertical translation upwards. Okay, so the mean value is effectively 1.7 take 0.5 divided by 2. Now 1.7 take 0.5 is 1.2. Excuse me, what am I doing? Not minus, plus. We want to find the average value. 1.7 plus 0.5 is 2.2. 2.2 divided by 2 is 1.1. Okay, so we already know, if we use this as a little bit of rough paper on the side, we already know that the tidal height, h, is equal to a, which is 0.6 times, so we're going to model it as a cosine function of n x take b plus 1.1. So what do we have to determine next? We have to determine the period. Okay, so if we look here, between 2 p.m. Tuesday and 11 a.m. Wednesday, how much time has gone past? So we've got 2 p.m. to 2 a.m. on Wednesday will be 12 hours, plus another 9, so 21 hours. Okay, so the period is 21 hours. Actually, that's not the period at all. That's the distance between when the boat has been away and when the boat has come back. Okay, so I'm actually going to change that. Excuse me. It's most definitely not a period. So the boat is out is 21 hours. Now, Looking at the graph, we can see that while the boat is out, we've gone from high tide to low tide to high tide to low tide. So what we have is we have a half period to here, and then another full period to the arrow here at the top, and then another half period. So that means that 21 hours corresponds to 1.5 periods. Therefore, of course, the period itself is going to be 21 divided by 1.5, which is 14. And n, as we know, is equal to 2 pi, because this is a sin or cos graph, divided by the period, which is going to give me pi on, pi on 7. Okay, so now we also have n, which is excellent. So if we move over to this side now, we now know that the period is 14 hours. Therefore, the value of n is pi on 7. Okay, so we're getting closer. So we've got very little to do now. We simply have to look that in a normal cos graph, we have a maximum at x equals 0 at the y-intercept. Okay, so if I sketch a cos graph for you, we have the maximum there. But if we read the question, the high tide occurred 2 p.m. on Tuesday, which is 2 hours after noon. And remember, noon is t equals 0. So what's happened, in fact, is that this graph has been translated to the right by 2 hours, because that's when the high tide took place. Okay, so first high tide is at 2 p.m. and that means t equals 2. Therefore, horizontal translation 2 units to the right. And as a result, we actually have all we need now. Therefore, tidal height, which we'll call h as a function of t, is equal to 0.6 times cosine of pi on 7 open bracket x plus x take 2, translation to the right, and that is plus 1.1. And there we have it. Okay, now I'm afraid my TASC calculator software doesn't seem to be wanting to work at the moment, so I can just show you on Desmos to see that we've got the correct answer. So height is equal to 0.6 times cosine of pi on 7 x take 2 plus 1.1. Okay, so hopefully that will show what we are looking for. Might change the axes a little bit so we can see what we're doing. There we go, and we'll show a little bit more time. There we go. So if that's noon, the high tide is 2 hours afterwards with a height of 1.7, which is correct. And then the low tide is 0.5 meters, so the boat goes out during one low tide, one high tide, and it comes back then, which is 23 hours after noon on Tuesday, and 23 hours after noon on Tuesday is indeed 11 a.m. on Wednesday. So our model is absolutely correct. Okay, now to determine the time of day on Wednesday when the tidal height is exactly 0.8 meters, of course what we want to do is we want to solve ht equals 0.8 for t. Okay, so we're going to really be doing that using our calculator, so I can use Desmos to help me here, but we do know that we want at what times of day on Wednesday the tidal height is exactly 0.8 meters. So if t equals 0 is noon on Tuesday, well, what we're doing is we are looking for solutions during Wednesday. So we are looking for solutions in the interval. So Wednesday will start 12 hours after, and Wednesday will last for 24 hours. So we are looking for solutions in the domain, solutions in the domain 1236. Okay? So what we're doing, of course, is we are wanting to solve this equation over the domain 1236. So if in this Desmos I simply put in my domain, so x is between 12 and 36, okay, so that is, those are the 24 hours of Wednesday, okay, and we want the height of the tide to be equal to 0.8. Clear doesn't like that, it wants y instead. There we go. All right, so judging from this, 0.8 meters, there are 3 times of day when the tidal height is 0.8 meters. Okay, so remember, 0 is 12 noon, so 12 is midnight on Tuesday, which is when Wednesday starts, and that day lasts for 12 and then 24 hours. So those times will be here, here, and here. Now, bearing in mind that these are measured in hours after noon on Tuesday, it should be very easy to convert those times into hours and minutes, especially since you can see here 0.667 is obviously 2/3 of an hour, so it's going to correspond to some number of hours and 40 minutes, and this is 0.333, so it's going to be some number of hours and 20 minutes. Okay, I think I can let you calculate those times. If you get into any difficulties, just let me know. Okay, there we go.